Hello, I want to welcome everyone to the RCR Wireless News Small Cells and LTE webinar. We will begin the webinar in about 2 minutes. All right, again, I want to welcome everyone to the RCR Wireless News Small Cells and LTE webinar. We'll begin the webinar in about 1 minute, just so that a little more time for people to join in. All right, let's get started. So again, I want to welcome everyone to the RCR Wireless News Small Cells and LTE webinar. My name is Dan Meyer. I'm Editor-in-Chief of RCR Wireless News. Today on the webinar, I'll be joined by Monica Paolini, who's the President and Founder of Senza Fili Consulting, Hongtao Zhan, who is President and CEO of Cellphone-Mate, Seth, Buechley, who is President of Solid Technologies, and Rupert Baines, VP of Strategic Marketing at Mindspeed Technologies, to take a look at the small cell market and how it relates to current LTE network deployments. The plan for today's one-hour webinar is to cover a handful of topics concerning the small cell and LTE space, providing an overview of the current market, provide some context as to how the space is evolving, challenges impacting the space, and what the future could bring for small cells in the LTE space. We will also have some input from equipment vendors on how they see the market playing out and where they fit into the space. The plan for today is to leave about 15 minutes or so at the end of the presentation for questions from those of you listening in. Please feel free to use the question function on the GoToWebinar tab that should be on your screen, and we will try to get to as many questions at the end as possible. If you have a question for a specific member of the panel, please put their name at the beginning of the question so we can make sure to direct that to the right person. For those that might have audio difficulties, we will try to speak as loudly as possible, but please make sure to check your audio settings on your computer or phone as you're dialing in. And also, for additional follow-up, we'll be releasing a report on this subject today that will be available on the rcrwireless.com website, and we'll be conducting several video interviews next week on the RCR TV site going over the same topic. For those of you who have maybe stumbled upon RCR Wireless News looking to get more information on the subject, here's a quick slide giving some background on RCR Wireless News. As you see, we've been covering the mobile space for more than 30 years and have a pretty lengthy history in covering the wireless ecosystem. So just to get started now, so obviously, you know, the LTE space, I think everybody's pretty well familiar with that, and also the small cell space is gaining a lot of traction in the market right now. Here's a couple of stats that we found working on this report, kind of touching on the opportunities that different analyst firms see for the LTE space and for the small cell space. Obviously, the LTE space is still fairly new, having first networks rolling out over the past couple of years, but small cells have had a little bit longer history in the wireless industry and have had a good chance to gain momentum. So obviously, from looking at the numbers here, whether they're from Informa or from Juniper, looks like there's some pretty good opportunities across the space for different vendors and different companies in the space. So to kick off the actual presentation, I want to bring on Monica Paolini, who I believe should be on the call. Monica, are you on the call? Or is she muted? Monica, are you there? Maybe I think we're still waiting for Monica to come on. So we'll bring Monica on here hopefully the next minute or so. Monica is with Senza Fili Consulting, and hopefully she'll provide some further insights into the small cell space. Let's see, do we have Monica yet on the phone?
Hello, can you hear me?
Oh, there's Monica. Yes, Monica.
Surprisingly, sorry, apologies about this. I had some trouble.
No problem at all. Well, thanks for joining us here. So yeah, just going over your slide here, just kind of giving some background on your consulting firm. Maybe before I start out, can you give us, I guess, a quick rundown just on your firm and on yourself?
Sorry, do you want me to get started?
Yeah, if you wouldn't mind.
Oh, yeah, sure. So at Senza Fili, we focus on any aspect of wireless technologies, and we do a lot of work from both the technology and the business models. And we've been working with vendors, operators, and lately I've been working a lot on the small cells and backhaul and business case. So today I'm going to be talking a little bit about all of this, and Wi-Fi. I was about to forget about that. Sure. So if we can go to the next slide.
Yep.
So this is what I'm going to be talking about today. The TCO model, business case for both Wi-Fi and small cells and how they're combined. And so what I'm going to start is with a little bit of a look backwards. Let's start looking at what happened over the last years, because I think this is interesting in telling us where we're moving to. So if you think about 5 years ago, which is when I started working on small cells, the model was really taken from Wi-Fi. So the idea was that Wi-Fi, it's very simple to install. You put an access point up there, and small cells seem to be pretty much the same. So there was very little in the way of hardware, and the idea was that it was very cheap to install and very low cost. As we moved 2 years ago, there was the reality started to kick in, and the question was, do we really need to have small cells? And what spectrum can we use? Can we afford them? How do we deal with interference if the small cells use the same spectrum as the macro cells? What about the backhaul? What about the role of Wi-Fi in relationship with small cells? Now that sort of debate was, I think, very productive, and we haven't resolved all the questions, but I think that right now there are some emerging trends and agreements that has emerged. So the first one is we really need small cells to address the increase in capacity demand. And the small cells require a new approach to network planning. So it's not just a question of installing a new cell, putting it wherever you need it. You need to do more than that. And while it is cheaper than macro cells, it is more expensive than Wi-Fi. And there are a lot of challenges that can be managed, but nevertheless need to be taken into account when planning a small cell deployment. And those include backhaul, interference, and really the details of installation, where you put them, permitting, and things like that. And what that means is that we need a new business models to support that. We can go to the next slide. So what I'm going to do today is to talk about this business case and look at different dimensions over which it can be optimized. And this is which interface, 3G, 4G. Do you want to add Wi-Fi, and if so, how? Now, here let me say something. Obviously, Wi-Fi is part of every operator's plan, and most are, well, all of them are using Wi-Fi upload in one way or another. Here, when I talk about Wi-Fi, it's not just to use Wi-Fi in the network, but to really integrate it with the small cells. And I will get back to that later. Should you use a small cell with one sector or multiple sectors? That's a new type of a new topic altogether. And then I will talk about share access and share backhaul. What an infrastructure sharing. So basically different ways in which operators can, operators or third-party players can work together to decrease decrease costs and improve the performance. Now, one thing here, when I talk about small cells, I basically mean small cells for public access, which are not, which could be indoor, outdoors, but they are not femtocells. They're not any residential or enterprise infrastructure. And they typically include Wi-Fi, and they could be either 3G or 4G. Now, if we can go to the next slide. Okay, so as I said before, there is an agreement in the industry that the increasing traffic load require more capacity. And the higher traffic load, I mean, this should be pretty obvious to all of you where I'm coming from here. There are more devices, more subscribers, more applications, and that drives the need for more capacity. Now, we have the technology to support some of that growth in capacity, and we can add more spectrum, but we can manage the traffic more efficiently. But ultimately, there is a need for higher capacity density. So it's not just the capacity across the footprint, but it's the capacity in the areas where demand is most concentrated, because demand is not uniformly distributed across the country. This is especially true in countries like U.S., where you have all the demand is much more spread out across geography. Less so in Asia and in Europe, but even there are huge variabilities in terms of the distribution. If we can go to the next slide. So this shows you how the capacity growth has happened. This is, if you look at the graph at the top, this is from Cooper. This is what happened over the last 45 years. Most of the increase in capacity has come from the fact that cells have been coverage has spread. So we have more cell sites, and mostly to achieve coverage. Now this is changing, because what we need to have is we need to go not in the width, not to achieve greater coverage, but we need to go in sort of depth to basically get higher density where cells already are available. And spectrum and technology will help, but you really need to work on the density. And that's also something that is under control from the operator, so it's an easier, it's not cheap, but it's easier to do. Next slide, please. Okay, so so given that we need to increase capacity, density of cells, how are we going to go about it? So the first way to solve this issue is to increase the number of macro cells. But at some point, you reach your expansion limit. You cannot put too many macro cells because interference is an issue. You just cannot find size order to it. So you can put small cells. And that's an efficient use of spectrum and network resources. You have a low per bit cost, and we'll get to that one. But the business case is still difficult because they're still expensive. And it entails a new deployment model. At the same time, because the spectrum that operators have is still the same, and in the macro-only environment, they have to deal with the issues of managing interference and also to provide backhaul to the small cells. You can also provide more residential femtocells. And I personally think that this is going to remain a niche market. It's an interesting market, but because wherever you can put a femtocell, you can also use Wi-Fi. It's often easier to use Wi-Fi, so that's sort of the dominant, the easier solution. But of course, there is the market for femtocells as well. And then there's obviously more Wi-Fi, both in the private and public environments. the costs are low, and there will be more integration with cellular networks coming up soon because of new technology developments. However, even Wi-Fi is limited because there's just so much spectrum allocated to Wi-Fi, and at some point we will run out of that. So basically, small cells and Wi-Fi, I think in this picture, are the most effective tools. And particularly, small cells and Wi-Fi are useful if combined. If we can go to the next slide.
And actually, right before we go to the next one, I want to remind everyone, too, if you do have some questions for our panel members, we'll have some time at the end here to answer those. So please feel free to send those questions in using the question tab there on the GoToWebinar control panel. And also, Monica, I think we're getting a little bit of feedback. Would it be possible for you to hit the telephone tab there on your audio portion of your control panel there?
I am calling from a landline because, so I cannot.
Well, there should be on your, oh, okay, so that should be what it is. Okay, well, no problem. So we'll see if we can work on it from our end. So anyway, feel free to go ahead. I'll put on the next slide for you there.
Okay. Thanks.
All right.
Yeah, thanks. Okay, so, you know, there is Wi-Fi and the small cells, and oftentimes have been depicted as two technologies that might substitute each other, and they're competing with each other. But and to date, they have been occupying a different position. So at the top here, there are some of the differences that we're seeing today in the market. So Wi-Fi tends to be indoor. There are a lot of deployments already. Wi-Fi offload is reality. There is more traffic in the cellular from smartphones that goes through Wi-Fi than it goes through cellular already. Residential offload is a major benefit, although we often talk about public hotspots, but most of the Wi-Fi traffic actually goes through your home. And operators benefit without having to build the hotspot infrastructure necessarily. There is a lot of infrastructure out there, and it's best efforts. Small cells, on the other hand, have been focused mostly in outdoor areas and urban areas. And the deployments are still very limited. Now, for Wi-Fi, there is the potential here is that with the introduction of hotspot 2.0 passpoint and SIM-based authentication, it will be easier to integrate Wi-Fi traffic with cellular networks, and that allows you to manage traffic more effectively from a network point of view, from an operator point of view. From a small cell perspective, the crucial challenges are interference, coordination, selection of backhaul, and site acquisition and lease agreements. Next slide, please. I realize that I have to go a little bit faster here. Now, I think that all of this points out that Wi-Fi is not an interim solution, but it's important to have it integrated with cellular because it will stay there. People will not stop using Wi-Fi, and so it's important that the two work together. Next slide, please. We are going to get into the results of the model. So I build a model to look at what happens if you have a deployment and you increase the number of small cells compared to the number of macro cells, and you add different interfaces, and then we'll look at what happens if on top of that you share the infrastructure. So here the first slide shows you that, as you can imagine, as you add more interfaces, the capacity per cell increases. So on the x-axis, you can see the number of small cells to macro cells, and on the y-axis, the capacity. So as you can see, the capacity increases as you would expect, and the small cell elements take on a larger percentage of the overall traffic as well. as it should be pretty obvious now. Let's move to the next slide to see what that does in terms of the TCO. Now here, what I look at is the TCO per bit cost. So basically, what is the relative cost of transporting a bit over LTE and 3G here? Now, as you can see, the macro is obviously the per bit cost for macro is higher. And if you look at the top one for LTE, the addition of LTE, so the first bar is macro only. The other ones are for macro plus small cells. And so if you go with LTE, you cut the cost by over half. Then you go Wi-Fi and gives you further improvement in cost. And then LTE, if you have only Wi-Fi. And then if you have LTE and Wi-Fi, you also reduce the cost a little bit. Adding 3G doesn't make much of a difference. Now, if you look at 3G, the situation is somewhat different. The 3G business case for small cells, if you only have 3G, it doesn't really look all that good. Because 3G, because the capacity is not that high, there is the relationship between macro and 3G is pretty macro and small 3G is pretty much the same, but the addition of Wi-Fi lowers the cost dramatically because Wi-Fi brings much more throughput. And then 3G and Wi-Fi is the cost goes up a little bit over Wi-Fi because 3G is more expensive. Does that mean that you don't want to have 3G small cells? Actually, it doesn't, because it's important to look at the per bit cost, but you also need to look at what you need out there today. And for a lot of operators, the congestion is in 3G, not in LTE. The LTE networks, where they exist, they are not at congestion yet. So operators are not in the need of deploying LTE small cells yet. And I think that this is what we're seeing in the market, is that there is a sense that things are not moving as fast as they could. And the reason is that the LTE small cells are not yet urgently needed, but the 3G small cells are. So my view here is that if you start, as an operator, you start deploying 3G small cells that are not, for which the business case is not really that strong, but if you put it in a perspective of having Wi-Fi in addition to them, to that, and being ready to add LTE as soon as the LTE network becomes available, then the business case looks fundamentally different. Now let's go to the next slide. Now here, if you see the per bit TCO for different infrastructure sharing, you can see that there is a different dimension in which you can improve the per bit TCO. So you first can improve by adding multiple interfaces, and then by sharing and using multiple sectors. Now, what that basically, I mean, this is a similar case that you can do on a macro infrastructure. You can share access and you cut costs. So, but here, what is important, what is interesting to see is how the cost decreases as you share different elements. So backhaul sharing gives you some cost, some lower cost, and enclosure sharing as well. Now, what this, from an Excel point, from a financial analysis, Excel point of view, obviously sharing is a good thing because it allows you to achieve lower costs. The challenge here is to see where it's feasible. In terms of deployment plans, in terms of competitive environment. Some operators are more willing to share and some are less. And notably, in the U.S., there is less of a tendency to share infrastructure. In the European countries, there is more propensity to do so. Now, let's go to the next slide. So this is one dimension. Another dimension to look at in terms of the business model is the backhaul. And there you have different solutions that, depending on what you are trying to, how much capacity you have, what are your requirements, might work differently. And I've done a lot extensive work on the financial implications of different backhaul. And I looked at different solutions, E-band, 60 gigahertz, and sub-6 gigahertz. Now, the important difference here is between the E-band /60 versus sub-6, which are more similar. So in sub-6 gigahertz, you have non-line of sight, or most likely near line of sight. And in E-band and 60 gigahertz, you have line of sight solutions. So as you can see from a cost point of view, from a TCO point of view, again, here we're looking, if you look at on a per megabit per second basis, the E-band and 60 gigahertz is much cheaper because they have, you get one link but much more capacity. So if you need a lot of capacity, that's a good way to go. But if you look at the TCO per link, the cost is somewhat similar. And in fact, it's lower for the sub-6 gigahertz. So if you don't need much capacity and you have spectrum, that's a good way to go. So depending on what your requirements are, there are different solutions that might be better suited. So what that tells us is that in terms of backhaul, there is going to be no single winning solution that will take care from a wireless backhaul point of view, because obviously if you have fiber and it's cheap enough, you want to use that. From a wireless backhaul point of view, you will see different solutions implemented in different environments. Now, if we can go to the next one. Next slide. So what are the implications of all this? The marginal cost of adding 3G and Wi-Fi makes their addition a compelling case. So it makes the overall business case much stronger, and also allows operators to address the need for demand in 3G networks today. And also, as if you have Wi-Fi and cellular integrated, so that you manage the traffic in a coordinated way, there is a huge advantage there in terms of offloading, real offload, to go beyond what I call the sort of the blind offload, which is what happens today, where operators offload traffic, but they have no visibility into that, and they don't know, they're not able to manage that. Next slide, please, and I'm going to close on that one quickly. So as we move, what can we see over the next 5 years? I think that the small cells deployment will make us transition to a new approach to network planning and management. The questions that are still outstanding is how do we manage interference? And here we don't know yet how all the new technologies like EIC and COMP work, because we just don't have enough data yet. And my view is that it might be worth eventually having a different spectrum band for small cells. And obviously, it's difficult to get more spectrum, but I think that eventually that's where we need to go. The other question is how deeply will Wi-Fi be integrated, and then look at in terms of the backhaul. How will the balance between line of sight, gigahertz or 80 gigahertz backhaul will compare to the near line of sight backhaul? And then, and finally, how will infrastructure sharing work, and will it work for small cells? And this is all from me, and I'll hand it over to Dan.
Perfect. Thanks, Monica. Definitely appreciate that presentation there, and obviously. A lot of the facts there that Monica brought up are things that we found also in the report that we worked on this topic too. So like I said earlier, if you guys are looking for some more information on this topic, there's a report should be available on our website, I believe today, on this topic, so you can get some more information from there. Also want to remind those listening in that if you do have any questions for Monica or for other panel members who are coming up, to please use your GoToWebinar control panel there. There should be a question tab. And you can put some questions in there. If you have a question for a specific person on our panel, please include their name in the question. And then the questions that we don't get to, we'll share those with the panel members too, so they might be able to follow up with you offline as well. So again, thanks so much, Monica, for that. We definitely appreciate that. So now I want to bring on some of our get some more insight from the equipment side of things on this topic. So first, I'd like to bring on Hongtao Zhan, who is President and CEO of Cellphone-Mate. Hongtao, thanks so much for joining us today. If you wouldn't mind, maybe give us a quick rundown of the company and kind of how you guys play in the space and maybe what you provide as a solution to carriers in the space.
All right. Thank you for the introduction. Our industry, the signal booster industry, we are solving the 4G LTE coverage issue and the spectrum efficiency problems from a totally different angle. We basically bring the 4G LTE signal directly into the building. That way, it dramatically improves the 4G, the LTE signal-to-noise ratio, and it's by doing so, it's dramatically improved the data rates. In many occasions, by 10x or more. And it's a solution that's very cost-effective. We as a company, we invented the false-5 technology, which covers all the carriers and all the LTE bands, and including all the 2G, 3G technology in the U.S. and Canada. I'll give you a brief idea. The dash system typically costs about $1 per square footage. With a signal booster, we typically cut that cost by 80% or even higher. It's a good solution if a customer, an enterprise customer or a consumer even cannot afford a dash system or a small cell solution, or even those solutions are not practical in many cases. Remember, for signal booster, we don't need a backhaul connection. The whole solution is totally wireless. It is an exciting time for our industry since the 4G has started, and there are a lot of new things will be invented in the next couple of years in our industry. I see that day to day. I see that firsthand, and we as a company trying to invent it as quickly as possible. It's exciting. I mean, obviously, our industry also faces challenges. One of the challenges is the regulatory uncertainty. We have been working with the FCC and the carriers for years on this issue. The good news is as a result, and the major carriers in the U.S., one by one, they're giving consent to signal boosters, as long as it meets a new proposed strict FCC spec. The most recent carriers that's giving consent in public is Verizon and AT&T. So all of a sudden, we're signal booster, we're as a whole industry, we're not illegal anymore. So that's wonderful. With that, I finish my introduction, and I cannot wait for the questions.
Perfect. Thanks so much, Hongtao. I appreciate the information there. And like Hongtao mentioned too, if you do have any questions, please feel free to use the GoToWebinar control panel there and send those in. The plan is to try to get to as many of those as we can at the end here, and we'll also be sharing those questions with our panel members, so there should be able to be some follow-up offline as well. Well, next I'd like to bring on Seth Buechley from Solid to give some insight on what Solid brings to the table and kind of a quick rundown on how the company sees kind of the space playing out. So Seth, thanks so much for joining us today.
Sure. Thank you very much, Dan. It's an honor to be on this call, and particularly appreciate the leadership role that RCR has played for decades in general, but specifically on these issues around LTE and small cell and whatnot. So could you advance the slide there, Dan? There's an awful lot of wiring required to make the wireless world a reality. And a little bit about our company. We're a public company. Our global headquarters are currently in Seoul. We're in the space of optics and RF amplification. Those are our core competencies. That's where most of our intellectual property lies. And so because we are a global company, we see different markets at different phases of adoption, and what Monica shared earlier really resonates with us. And so the areas that we're most active, for instance, in North America, would be the DAS space. Whereas in other countries, we're finding that DAS is not really playing a prominent role, but in Asia, they're more active, for instance, with backhaul of small cells already. Mm-hmm. And we think the entire world is moving more towards all optic in-building solutions. And so just breaking that down a little bit, so in the lower left hand here, we have our DAS practice. And our focus was really on listening to the enterprise, the building owners, and helping the wireless operators deliver services inside those venues. And as I mentioned earlier, it takes a lot of wiring, a lot of fiber optic cable to deliver radio signals inside those buildings. And when we kind of struck out to innovate in this area, we chose also to take on an emerging issue, which was the requirement for public safety inside the indoor environment as well. And so our DAS products are primarily indoor. We do have some outdoor elements to them, but they're primarily indoor, and they're primarily focused on bringing cellular capacity and coverage as well as public safety into that environment. When you kind of move to the top of the slide here and you look at our optical business, most of where we're focusing on today is delivering small cell backhaul to wireless operators, and also allowing CLECs and other people with a lot of fixed fiber to more efficiently use the fiber they have in the ground. So, I think somebody said once that the average, fiber optic per mile cost is something like $40,000 if you have to plow it in new. And so obviously everybody would like to do more with their existing fiber. And so that's a huge growth area. We just finished a very large LTE backhaul deployment in the Seoul metro area. We had over 100,000 LTE nodes connected. And what's been fascinating is you see the evolution of the early adopting countries like Korea, where initially everybody goes through the same process. They kind of resist this idea that they have to connect everything with fiber, and then eventually they say, you know what, I really need to do it. And once they do it, we begin to see that there's all sorts of other things that can be done once we're there. And so we're also going to be announcing at Mobile World Congress some game-changing solutions to solve the problem that Monica put so well, which is blind offload. The carriers are having a difficult time from a security standpoint just dumping their subscribers into a Wi-Fi solution when they lose all of the normal security and user experience metrics that they've worked so hard to build. And so Wi-Fi offload and doing that in a more intelligent way is something we're spending a lot of time on, and we're going to make an announcement at Mobile World Congress. And the last piece, very briefly, is when major hoteliers or others are trying to understand what kind of infrastructure they should be putting in their building, they're wrestling with what kind of infrastructure should be laid out. And the one thing that they're settling on is we need to go to optics as quick as we can, because those optics and getting that optical network at the building level and out in the streets is really what's going to make the small cell and LTE rollout possible. When you talk about 10 times the number of cell sites that you currently have, obviously getting fiber to each of those cell sites is a huge point. So Thank you, Dan. I look forward to any questions.
Perfect. Thanks a lot, Seth. Appreciate it. And also for those who might know Seth from his regular work at Solid, he's also always attending a lot of the events. So if you ever want to follow up with Seth, you can always find him at a lot of the small cell events going on. So feel free to track him down there. Thanks again, Seth. So and finally, I'd like to bring on Rupert Baines, who's the VP of Marketing at Mindspeed. Rupert, thanks for joining us today as well. And if you wouldn't mind, give us a quick rundown of Mindspeed and kind of how you guys play in the small cell space.
Hello, everyone. Thanks very much, Dan. So to introduce myself, as Dan just said, I'm VP of Marketing at Mindspeed. Before that, I was VP of Marketing and on the exec team of PicoChip. And that is, we make the technology that makes small cells work. PicoChip very much pioneered technology. We were acquired by Mindspeed early last year, and together we now are the dominant technology supplier into the small cell space. Infinetics put out some data the other day that something like 63% of the small cells in the world are using our technology, our silicon chips. In addition to that, I am also on the board of the Small Cell Forum, the industry association. And just to put in a plug for the forum, if you are interested in this topic, smallcellforum.org, there's a whole host of information. Any companies, operators who are interested really should be participating in the forum, and we will be doing a lot of activities as an organization in Barcelona at MWC. So if you're going to be at MWC, please do come to the forum's stand to find out. So Mindspeed, we make the chips. This is the fundamental part of it. Monica touched on something about this, but I think it's worth reiterating. One of the standard features in technology is the move that things become integrated into a standard chip and a reference design. And that is how you can get volume, and that is how the economies of scale and the costs work. We saw it with DSL, we saw it with Wi-Fi, and of course we saw it with computers as you move from mainframes with custom silicon to PCs with standard silicon. And we're driving the same change for wireless infrastructure. So the reason that small cells can be so much cheaper, the reason they can be so much easier to deploy, very similar to Wi-Fi, DSL, or the PC, is the advent of standardized silicon and standardized software to make it possible. These things are real. It's worth reiterating, just this is not a future subject. This is very tangible, very much happening now. According to Informer, according to ABI, there are now about 5 million small cells in the world. The majority of those are the residential ones that Monica mentioned, but there are a number of operators, Telefonica, Vodafone, SK Telecom, KT, SoftBank, with commercial use of public access metro area small cells. And many of those are now launching their LTE small cells today, as we speak. Again, there will be many announcements about this in Barcelona. But it's worth seeing this technology real and available. That is probably about my time. So, sure. Dan, shall we move over to questions?
Yeah, we'll do the Q&A now. Obviously, thanks a lot, Rupert, for that. And like Rupert said, I'm expecting, I think everyone's expecting, probably quite a few announcements coming up at the Mobile World Congress event. I think week after next, I believe it is, in Barcelona. I'm sure there'll be a lot of announcements there on these topics as well. So again, Rupert, thanks so much for the presentation there. So now let's move on to the Q&A section here. We've got about 15 minutes left for the webinar, and from the looks of it, we've got a lot of questions, so obviously we won't be able to get to all of these, but I do want to remind everyone that if you send in a question, we will be sharing these questions with our panel members, and so perhaps there could be some follow-up offline as well for these. So definitely thanks for the question on these. So looking through, we'll start with one here that's targeted at Seth. Someone's asking if you can discuss the DAS versus small cell versus smart cell, I guess, trio there. I guess your kind of views on how those three play together in the space.
Sure. Well, I won't try to tackle the smart cell from a definition standpoint. But I can tell you with regard to DAS, our view of DAS is that it's just not very intelligent at this stage. The mission of a DAS is to take the intelligence found in the base station and the capacity and the coverage and to move that throughout a large venue in much the same way that plumbing moves water. Our vision and understanding of what small cell is that small cell is going to be a bunch of small, low power, low height radio elements that are connected in themselves to the core network, but also connected to each other. And so they're small in power, they have the radios at the very edge, and they're talking to the core network and they're talking to each other. And of course, they're all connected by fiber or non-line of sight, microwave, and those kinds of things. So that's how we delineate DAS versus small cell. We don't see that it's a winner-take-all kind of discussion. We think that they will be used in concert over the years.
Great, perfect. Thanks a lot, so much, Seth, for that. We got some more questions here. I think one is here for Monica. Someone asking about, I guess, in Europe, kind of the view of small cells there. A person asking that looks like the carriers there are acquiring fixed line assets to provide competitive bundled services and cut down on tower layering costs. I guess what's the view there on how small cells can be useful, I guess, for maybe more of a European operator?
Well, in Europe, well, there is an interesting situation because you have higher density, although the usage is a little bit, the traffic per user is a little bit lower. So operators are looking at small cells, but by and large, they don't have big LTE networks. So initially, they were sort of waiting for LTE and you know, to just have the LTE small cells. But what's happening is that they realize that they do have congestion issues, and they need to increase the capacity over the 3G network. So they started to look more with bigger interest in the 3G small cells. But at the same time, you know, Wi-Fi offload is also very sort of a much easier and short-term route to follow. So what you see a lot of operators, they try to maximize the capacity, well, maximize the benefit of Wi-Fi offload before they launch into small cells. But there is a lot of interest. They're doing a lot of trials, and I think that's going to be a very interesting market for small cells.
Gotcha. And yeah, sorry, someone else have a comment? No? Okay. All right. Actually, I know another topic here, and that's kind of brought up by the presentations as well, was kind of the spectrum issue. I know, Monica, you mentioned this as well, and this seems to be probably a big issue for a lot of countries. Is, you know, whether to set aside specific spectrum bands for small cells. Someone is here kind of asking, I guess, what the issue is when it comes to being able to set aside spectrum for small cell deployments. I know a lot of carriers in some countries don't have that kind of luxury to be able to set aside certain spectrum bands. So maybe Monica, if you can touch on, you know, I guess the view of how that spectrum crunch is maybe impacting the deployments of small cells, and then also from the other panel members too, if you have any insight you want to bring on kind of the spectrum issue and how perhaps different solutions can work around the spectrum issue. So maybe Monica, if you want to start with your view on the spectrum issue.
Well, that's really a difficult question, you know, because there's just so much spectrum out there, and you know, you can argue that you want to have more. But let's say you even have more spectrum. How do you use it? And right now, operators are the initial strategy is to have small cells and macro cells using the same channel. And that's obviously attractive because in theory you can use your spectrum more efficiently, so you can squeeze out more megabits per second from the same amount of spectrum. So if we leave all the regulatory and spectrum availability aside and you say, well, okay, let's look at one operator that has a certain amount of spectrum, the question is how do you maximize the utilization of that spectrum? So the initial approach was to just use the same band for both macro and small. But in my work, there are a lot of very interesting technologies that are designed specifically to do so. But as the number of cells increases, and this is in the long term, I'm looking at the long term, we might get into a situation where operators, no matter how much spectrum they have, they might want to dedicate some of the spectrum for small cells only. And the reason there is that it's easier to coordinate, it's easier to coordinate the macro and small cell layer if they're using different channels. And so I think that it's an empirical question of what is going to work better. But there are some issues. For instance, if you have both macro and small cells on the same channel, you need to use the X2 interface to coordinate transmission, and that requires a very low latency. And that might be difficult to achieve. So there are a lot of dependencies that are there, but if you want to use the same spectrum, and that might make it not as efficient. But I do not think that we have the answers yet. So I put this as a question mark rather than as an answer.
Gotcha, gotcha. Well, maybe Rupert, actually, I don't know if you have any insight. I know obviously you guys provide a lot of equipment for the kind of the inside of the small cells and having to deal with different spectrum bands in there. I don't know if you have any insight on kind of the issues that come up when it comes to having to have specific spectrum bands for small cells.
Agreeing with Monica, I think in the very early days people expected they would need dedicated spectrum. The experience to date from most of the deployments has been shared spectrum, so using the same band for both the small cell layer and the macro cell layer, and that has worked very, very well. What we're seeing now is as people are starting to talk about comp, as we're starting to talk about interference cancellation techniques, the smarter techniques that might use coordination, that would use the X2 interface, then that is coming back for study, because maybe, as Monica said, although things work perfectly well in shared spectrum, there might be ways that we can make them work better with these more advanced techniques. Just one comment that people may not appreciate. It sounds a little counterintuitive, but actually what happens is the more of these small cells you put in, the better things get from an interference point of view, because you're reducing the signal, you're reducing the noise. Because people have a nearby base station to talk to, then they don't need to shout as loudly, so the amount of noise in the cell goes down, and so everyone benefits. So it seems a little counterintuitive, but the more of these things you put in, the less noise and the less interference there actually is, and the better it is for everyone.
Got it, got it. Sounds like a little bit of RF voodoo there. So, but yeah, but like you said, that can actually help the situation. So, well, I guess talking a little bit on the interference issue. Obviously with boosters, that's kind of been a concern for some in the past. I don't know if Hongtao with Cellphone-Mate. I don't know if you have any kind of insight on how the interference issue is kind of being worked on with carriers and these smaller deployments.
Oh yes, definitely. Thank you very much for the question. It's an excellent question. Matter of fact, we've been working on this issue for more than 10 years. So that's the issue we know. That's the issue we saw. So first of all, I give you some big picture ideas. Let's look at the numbers. Based on the multiple marketing research sources, 2 million units of signal booster has been shipped as of today over the last decade or so. So that's a huge number, 2 million. Very few of those, in terms of percentage, has causing any interference incidents. We're talking about hundreds. We're talking about 0.1%. It's all 0.0, 3% or whatever. And the technology is improving every day. We see a lot less. Actually 10 times less interference incidents happens. In terms of percentage over the last 3 years. So the technology is improving dramatically. Obviously, in our industry, the mechanisms of how interference happens is well known. So it's not rocket science. This thing, it's already understood, it's solvable, it's purely technical problem, and we almost solved it as an industry. That's why if you look at the what's going on with FCC and the carriers, both FCC and carriers are now willing to accept the signal booster as a solution because of that. That's the facts. 2 million being shipped, and at least over 1 million is currently operating in the U.S. Remember, those are wideband signal booster that amplifies all the signals from all the carriers. Of course, we're talking about 2G, 3G. Cellphone-Mate happened to be the first one and the only one come up with the 2G, 3G, 4G solution. All in one box. Yeah, it's not easy to put all the wideband 5 amplifiers, actually 10 links in the box without causing interference. But we've done that. It's in volume shaping, and we don't see a lot of interference issues, incidents, and the key, I think, is you don't want to generate the interference to begin with. You want to design and manufacture an amplifier, not an oscillator, right? So that's the key. That's what we do. That's what we, differentiate ourselves, from a lot of competitors. So that actually is the name of the game in our industry. Who generate less interference, causing no trouble to the tower, and we showed it can be done. So does that answer your question?
Yes, that works very well. So I think we have time for maybe one more quick question. I kind of want to throw this one maybe to Seth. I know obviously Solid has a lot of expertise when it comes to kind of the small cell DAS space, and there's been some questions on here kind of about the overall integration of all these technologies together. I don't know if you have any insight in kind of how you see this playing out, where DAS can also support Wi-Fi, and how small cells can all be integrated with the general macro cell as well, where there's a seamless operation of all this at some point down the line. Do you see that happening, or how do you see that, that part of it playing out over time?
Sure. Thanks for the offer. Well, first, I think context. I think we're somewhere around 100 million LTE users at this point, and so just the growth of the market will drive innovation and change, and people will have to try new things. For us, we're proud of our DAS business, but we think that there's a transition about to take place, which was more all-optic infrastructure. And so, for us, we see that it's going to be impossible to migrate another evolution of DAS to get to the point where we integrate Wi-Fi and DAS onto the same infrastructure until that infrastructure is almost exclusively optic. Meaning it's going to happen, and it's going to happen soon, but it's going to require transitioning to an all-optic architecture. And so we have, for us, we have a DWDM PON. We call it our Infinity Access Platform, and essentially what you can do with these kind of technologies is you can take a piece of fiber and you can start to channelize it by breaking it into lambdas. And each of those channels can essentially do what an original fiber could do on its own. And so those are the kind of technology advancements where, say, you run a piece of fiber in the in-building environment, for instance, and one of those, on the same piece of fiber, you might be able to run an IP camera, you might be able to run an LTE radio node, you might be able to run an access point. All of that runs on the same infrastructure. So the challenge isn't that the technology is not evolved. The challenge is that the ecosystem hasn't evolved. And, of course, with any disruptive technology like LTE is, part of that process is the incumbents, which are very well entrenched, have to get comfortable or have to figure out how they play or determine if they're going to resist these kind of groundbreaking changes. And so, that goes all the way up and down the chain. If Monica's vision of network sharing is a reality, what does that mean to the tower companies that make their business today by leasing out macro sites? What does that mean for cities when they start to look at their right-of-ways as revenue generators for all the small cells? And there's a lot of questions like that to me are the questions that have to be answered before this wide adoption happens. But the technology is emerging. It's the business models and our thinking which is catching up.
Got it. Well, appreciate that. Well, Seth, thanks so much for that reply there. And again, I want to thank everyone for joining us today. It looks like we might be a little bit over our time, so just want to thank all those who stuck with us here. Also, for all the questions that we did not get to, and there were quite a few, like I said earlier, we'll share those with our panel members who can follow up with you offline as well with those. So hopefully we can get those questions answered at some point here. Also, I want to let everyone know that the webinar will be archived on the rcrwireless.com site. Should be there in a couple of days. So if you want to look for that to replay this, or also check out, we'll have our feature report on this topic on our site. It should be there later on today as well, and that might have some more information there for you. And also, next week, we'll be doing some video interviews with some of our panel members that'll also be on our website. So there might be some more insight there as well on this hot topic. So please look for those. Well, again, thanks to everyone for participating today, and a special thanks to our panel members, to Monica, Hongtao, Seth, and Rupert. Thanks a lot for providing the insights, and thanks a lot for everyone for joining us. We appreciate it. Thanks.
Happy Valentine's.
Thank you.
The organizer has ended the session, and this call will be disconnected. Goodbye.